Hello everyone, I'm Dr. Mehraei, and today we are going to talk about hypothesis testing. Hypothesis testing includes some steps and components. We are going through the most important ones and we could say even tricky ones. Alright, for first thing we should know is about H0 and HA. We call them null hypothesis, H0, and alternative hypothesis, HA. In some books, they show it with H1 as well. We should know that these two should be mutually exclusive. It means that there should be no intersection between them. So we don't have, for example, mu equal to mu zero. At the same time, we have mu more than and equal mu zero. So we should be careful that they should be mutually exclusive. Okay, the next important thing we should know about hypothesis testing is test statistics. So first, we consider null hypothesis as the claim that, for example, a company has or a researcher has about the data. For example, we say that the average height of students in Metu is equal to 165 centimeters. So this is the claim that we are having. We can either accept or reject this hypothesis. How we can do that? By running the hypothesis testing. So H0 is when the population mean is equal to 165, and HA, alternative hypothesis, is mu not equal to 165. So that number, we call it mu zero. We show it like that. So this is basically a number. Okay, so next thing to do in order to find the region of rejection, as we call it, I will show you on the graph as well, and to compare it with that region, either as a test statistic or p-value, then we should calculate test statistic, which is very important to finalize an answer when we want to reject or accept H0 or HA. So please go through these examples of the book for more practice. Right, there are two terms which are very important, alpha and beta. We already know about alpha. This is actually our significant level. We talked about it. When we say about confidence level, it was 1 minus alpha, right? Now, beta, on the other hand, we call it type 2 error. So type 1 error is alpha, as we knew it before, and type 2 error is beta. But what are they exactly? So in terms of rejecting or accepting H0, if we run a test and we reject H0, but in fact it was true, H0 was true, we shouldn't have rejected that. So in that case, we made a mistake and we call it type 1 error. In case if you accept H0 by mistake, like it was actually false, but we accepted it. So in that case, we call it type 2 error. We have some other terms too. Please go through them carefully. One of them, for example, is power. Power is 1 minus beta, your type 2 error. So we have now confidence level, we have power. So these two are nice to be high in order to check it more accurately. But it doesn't mean necessarily that it gives you a good result at the end, and we will talk about why I say this. All right, so test statistic is important, and that's why we should know how to calculate it. Take a look at this one. It looks familiar, right? It's like making a z-score, and this is a specific type of z-score. That's why I chose 0 for it, so that you remember this is related to test statistic. In some books, they don't even show an index yet. Some, they show z alpha. And z alpha actually calculated by the significant level. But whenever you want to calculate test statistic, it's nice to show with z0 so that we don't make, we distinguish it with z alpha, which is based on your type 1 error. That's why it's better you guys to use Z0 as well. And the other difference between the formula that you had before in order to make this score was this mu0 now. As we said, mu0 was just a number. Like, for example, if you have such hypothesis, then you can find the value here from the beginning. So if, for example, mu is equal to 165, so inside this formula, instead of mu0, write 165. Because we should have all the informations here in order to write the final answer for our test statistic. There are some summaries about z-test and t-test. You can see also I put here some information for you for t-test. You can go through them. It doesn't cover all of the cases. In the lecture about confidence interval, I explained for you about all possible cases. There are no more cases there. That's why this table is not complete. I suggest you for that, please go through my previous lecture about confidence intervals to know about them. But this is not bad anyway to remind yourself about some part of it. All right, so assume that we know about H0, HA. We know about our test statistic value now. The next thing to do is either accept or reject our hypothesis. So there are different scenarios, and all of them depends on your HA. In order to find the rejection area, as we call it, here, for example, or here, or on both sides, in order to find it, you should take a look at your alternative hypothesis. This note is very important. So how do I understand about my rejection area? By looking at my HA. So the next thing to do is to find your Z alpha. What is the alpha? The Z score corresponding to your alpha. What is alpha? Type 1 error. How can I calculate it? 1 minus your confidence level. And so I showed my rejection area like this. If Z alpha is here, so rejection area is on the right side of it. So when I calculate my test statistic, we show it here by T. Don't mix it up with T student. And this is just test statistic. And we should check whether this T falls inside acceptance area or rejection area. If it is inside acceptance area, it means that I accept H0 with that confidence level, which is 1 minus alpha. If it falls inside here, then you reject H0 and accept HA by that confidence level. So there are different scenarios. We will talk about them. And please be careful how it happens that we have t-test and z-test. Because sometimes, based on the cases, we should calculate z-score or t-score. And we should read the final answer from the tables, right? From, for example, normal standard distribution or t-student distribution. That's why we had such summary before starting that area. So please make sure that you read the confidence interval before going through all this. And in case when we have the rejection area only on the right side or left side, we call them one-sided. In case they are distributed on the both sides, we call them two-sided. And why they are important? Because the confidence level is the same for all of them. For example, I say I want to be 98% sure that my test will be okay. So in that case, for example, at the end, I say with 98%, I'm sure that I rejected H0 correctly. And for alpha over 2, because we have both on the right and the left side, when I want to calculate these areas, I should calculate not 2% like these two, but for 1%, alpha over 2, because we divided this area into two sides now. We should be careful about it. Okay. There's another term. So far we know how to reject or accept our H0 using test statistics. Another way is to use p-value. P-value is very confusing for a student at the beginning, but this term is very important, and in most of the tests for statistics, you will see that they use p-value. But what is p-value? P-value is actually the probability related to your test statistic. It means that if your test statistic is here before z alpha, for example here, then we should calculate the probability, cumulative probability of that, like probability of z less than this test statistic. If, for example, a test statistic happens to be 162, then what's the probability of z less than that? It never happens because that 160 something should be converted into z-score, then we will have a value most probably less than 3.4. So what's the probability of z, for example, less than 1.2? If I'm talking about this graph, so if this is around this area, we could accept such a number. So the area that starts from this point and we add all of them together, then that area we call it p-value. Sometimes it can fall before or after the area that we have for alpha. So what's happening here? Whenever I talk about testing, hypothesis testing, hypothesis using test statistic, then I'm talking about z alpha, which is here, and your test statistic. If it falls on the right side of it, for example, in this example, then we accept H0. If on the left side, then we reject it in this case. But you know, there are several cases that we should be careful when we should reject, when we should accept them. And when we talk about p-value, we should know what is alpha. Is it located on the left side, right side, both sides? We should be careful about that by looking at our HA, see? And then compare it with our p-value. Okay, so another thing I want to show you with details is related to how we construct or how we show it on the graph. We illustrate it using HA. For example, here I showed using median, but even for mu is the same story. Like if your HA is mu less than 30, by the way, if this is the case, what is H0? Can you tell me? As I said, it should be mutually exclusive, and usually we write the complement of that. So H0 most probably was mu more than and equal 30. Okay, so it's good enough for me just to show HA. And based on HA, I understand median here, or you can consider mu instead of it for mean. Mean is less than, for example, 30. Then in that case, I understand that this should be this on the graph, and I want to illustrate it. This rejection area should be on the left side only. Okay, this is very important to notice. So if this is less than, on the left side. If this is more than, on the right side. You see, that's so easy now. And if they are not equal, this is the case of two-sided that we keep talking about. So when they are not equal to something, either median, mean, or later we will talk about variance, about ratio, like for example, for binomial distribution, all of them. If we have such a case that it's not equal to 30, it means that it's either more than or less than. So at the same time, more than and less than, we should cover them here. And that's the reason alpha will be distributed in two parts, in two segments, one on the right side, one on the left side. And that's the reason we write alpha over 2. And exactly that's the reason in confidence interval we write for z-score 1 minus alpha over 2. So now you can see the reason for that, because we are calculating this area, right? Okay guys, I know these days it's even hard for Mona Lisa to put a smile on her face, but you guys, you should do your best to be hopeful it will pass too. Stay home and let it pass sooner. See you guys.